All right, so here we have a circuit. We have a 60-volt source. We have 6 resistors and a series parallel combination. The initial part here is to ask for the equivalent resistance of the circuit. We know every resistor. We know how they're arranged, so we can always simplify a circuit down to one resistor that would be the same as all of these in combination. So let's look at how we are going to set this one up, and this is pretty complicated, so we want to definitely be methodical about how we break through it. We have 2 main methods for breaking it down. One is a general redraw, where we kind of draw everything straight across from left to right, as if you have charge leaving this positive end. So I'm going to kind of reference that with something coming out of the positive, going through the 5, and let's call that node A. All right, so I'm going to start with a positive end. I'm going to go through a 5 ohm resistor, and I'm going to go to node A. All right. At A, we get 2 splits. We get a split this way, and we get a split that way. So I'm going to reference that just with the split here. All right, let's stay on the high road. Now A immediately goes to another split. So I'm just going to move that along. Let's call that B. And at B, it splits another 2 ways. So I'm going to split it twice. And if I stay on the high road, I'm going to go through the 22, down through a 10, and then to another node. So I'm going to draw that in here. There's my 22. Here's my 10. And I'm going to go through to another split. Let's look at the low road. I'm going to go down through the 30 to the 7, and I'm going to go to that same node. We'll call that C. So I'm going to, down here, go through 2 resistors. That's a 30 and a 7. And here's where they both meet up at location C. Now C is going to move over here, back to this node. We haven't labeled that. We'll call that D. Coincidentally, we go A right to D. So A goes through 1 resistor. We'll call that an 18. And then C merges with D, and then we make it back to our power supply. All right, so by drawing it this way, to me, it's really helpful to see, hey, if there's 2 pathways, we're in parallel. Otherwise, we're adding things together. So we can start to simplify this right where we stand here. So anything in line with each other, like the 10 and the 22, well, I can rewrite this as a 32. Remember, series, we add them together. And a 30 and a 7, I can rewrite as a 37. And those are in parallel with each other, right? You have an upward branch and a downward branch, and so we should get something. The smaller resistor is 32. Half of that is 16. If it was 32 and 32, I'd be at 16. So it's 32 and something a little bigger. Maybe I'm looking at like 17 as a value here. So let's see. So we're going to say 32 to the -1, that's 1/32, plus 37 to the -1, which is 1/37. Sorry, let me adjust that. This whole thing is in the denominator. Second insert. And if you make it a denominator, it's the same as raising it to the -1 power. So that's kind of how I would address that one pair of branches here. And so that 32 and that 37, sure enough, we get 17.16 as the combination. So this whole combination from all the way through here to there, that whole combination is the same as 17.16. And if you notice, from A all the way to D, you go through that whole mess up top that's equivalent to 17.16, or you can go down below, that's 18. And so really I have that value in parallel with 18, which should give me somewhere about half of that, right around 9. So I'm going to raise that to the -1. I'm going to add 18 to the -1, which is 1/18, and take that whole thing to the -1. And so what I've got is 8.78 is now my equivalent resistance of this whole mess between A and D, right? 8.78 ohms. All right, so I've effectively simplified all 5 of those resistors down to 1, and it looks like we have this 5 ohm resistor that is getting added to that, and so you get a total resistance of 13.78 ohms for my equivalent resistance of that circuit. So that's one way to look at this, is to do this redraw method. Another way to look at it is as I posted on Blackboard, we can look at our power supply and go far away from it and identify resistors that are only in series or only in parallel. And hopefully you see if I take a branch right in here, I have to pass through the 22 and the 10 together, which means I have a combination of 32 ohms. And the same thing happens here. This combination, again, is 37. Notice we have a similar thought process once we redrew this circuit, but I hope you would be able to see that that's the case. Now, when I get to B, I could go down or I can go through. So really 32 and 37 are in parallel with each other, and we calculated that to be 17.16. And so now I can effectively redraw this whole mess as one 17.16 ohm resistor, and that is in parallel with your 18, which we saw down below, and then that gets added to our 5, and we get one big loop. All right, so again, you can kind of work through the same redraw that we did down below just by identifying those pieces in the original circuit. So it's really, the more practice you get, you'll start to identify these pathways. Sometimes they're visibly tricky to see based on where they drew those resistors. Sometimes they look parallel because they're parallel lines, but that doesn't necessarily mean they are parallel. So we really have to look at what pathway could I take as an electron passing through these wires. And if I pass through consecutive resistors, I have to add them. And if I have two options, then I have parallel. Hopefully this is a good example of a pretty complicated circuit where we get a redraw to find an equivalent resistance.